In this video, we will analyze a couple of functions, exploring things like domain, range, maxima, minima, x-intercepts, y-intercepts, and end behavior. Oh yeah, increasing and decreasing intervals. So the domain is all about the x values. So we're talking about how far the graph goes to the left and how far the graph goes to the right. Well, this graph goes to the left forever, and it goes to the right forever. It's unending on either side. So the domain will be from negative infinity to positive infinity. Okay? Similarly, the range is all about the y values. How far does the graph go down, and how far does it go up? Well, this graph goes down forever and up forever. So that is also negative infinity to positive infinity. All right, absolute maxima. What is the absolute maximum of this graph? What's the highest point of the function? There is no such point because the graph goes up forever. So for absolute maxima, we say there are none. All right, maxima is the plural of maximum. What about local or relative maxima? Well, it looks like this spot right here. Wait, I want yellow, though. This spot right here is going to be a local maximum. It's not the highest point on the graph, but it's the highest point on the top of this little hill. So that is this point 0.8 comma 6.2. Okay, so we'll just write that down. 0.8 comma 6.2. What about absolute minima? There is no absolute minimum because the graph goes down forever. So once again, we will say none. But for relative minima, that's going to be this point right here, all right, at the bottom of the valley, negative 1.6 comma negative 1. So we'll just write that down. All right, what about the zeros? Well, the zeros of the function are the x-intercepts of the graph. And the x-intercepts are here and here. So that's at negative 1 and negative 2. Okay, so we could say negative 2 comma 0 and negative 1 comma 0. All right, the zeros are just the x-intercepts of the function. Y-intercept, well, there's only one y-intercept, and it's right there, 0 comma 4. Okay, now let's talk about the end behavior. As x approaches negative infinity, comma, f of x approaches. So this part means on the left. Okay, as we go to the left. So we're talking about this end of the graph. So as we go to the left, on the left side, the graph goes up. So that's why we'll say the function approaches positive infinity. So again, this means on the left, the function goes up, positive infinity. Now this part means as x approaches positive infinity, that's a fancy way of saying as we go to the right. So, so now we're looking at this end of the graph. All right, so as we approach this end of the graph, the function is going down. So that's why we'll finish off with a negative infinity. Okay, on the left it rises, positive infinity. On the right it falls, negative infinity. Okay, now let's talk about intervals of increasing and decreasing. The most important thing to remember about intervals of increasing and decreasing are when you do these intervals, we are only talking about x values. Okay, x values. Only x values. So what I have encouraged you to do is to go through the graph marking off all of the x values. Okay, so let's see, what's the easiest way to do that? So at this point, you know what? Hold on one second. Okay, so we have this point right here. All right, these are critical values. Here we have an arrow, and here we have an arrow. So these are the 4 x values we need. So let's deal with the arrows first. Forget about the fact that this one is up and this one is down. As soon as you say up and down, you're talking about y values. Y values go up and down. We don't care about that right now. We're doing only x values. X values go left and right. And when you're dealing with arrows, you're dealing with infinity. On the left, you're dealing with negative infinity. And on the right, you're talking about positive infinity. So this arrow over here on the left is approaching negative infinity. So that's the x value of this arrow, if you will. Okay, this arrow over here on the right, okay, that's positive infinity because it's heading to the right. So the x value of this arrow is positive infinity. Now, as far as these other points, I gave you the x values straight out. So this is an x value and this is an x value. Alright, so these are the 4 things that we're going to use. Negative infinity, negative 1.6, 0.8, and infinity. Nothing else will be written in this series of increasing and decreasing intervals. Now, if you were tracing this graph from left to right, part of the way you would be going downhill. So I'd be going downhill from here to here. Okay, and then I would be going uphill from here to here. And then I would be going downhill again from here to here. All right, downhill, uphill, downhill from left to right. So if I want to talk about increasing intervals, it's this one green uphill part. So looking at the x values, that goes from negative 1.6 to 0.8. Negative 1.6, comma, 0.8. Now this is not an ordered pair. This is an interval. It's saying we're starting here and ending here. This is interval notation. All right, we always use round parentheses for interval not for interval notation, for increasing and decreasing intervals. We're leaving out the point right here at the very end. We're leaving out this spot because it's decreasing on the way to it, it's increasing on the way from it, but right at this point it's neither increasing nor decreasing, so it should not be included in the interval. Similarly, for intervals of decreasing, well, we've got 2 of those. The first one goes from negative infinity to negative 1.6. Okay, union, because we're going to have another one. And the second one goes from 0.8 to infinity. All right, and that is how you analyze a function. Okay, now let's do the same thing one more time to this graph right here. Well, the domain is once again going to be negative infinity to positive infinity because of the way the graph goes left and right forever. The range is all about the y value, so that's bottom to top. All right, the bottom of this graph goes to a low of whatever this is. And you know what? This y value tells me exactly what it is. That's negative 2.8. So the range is going to be from negative 2.8 to infinity. Okay, because it goes up forever. So bottom to top, that's negative 2.8 to infinity. We will use a square bracket because the graph comes down and reaches negative 2.8. So there's no reason to leave that value out of the range. The graph reaches it. The point 0.4 comma negative 2.8 is right here on the graph. It is part of the range. So we won't leave it out by making it rounded parentheses. Anyway, let's talk about absolute maxima. All right, is there a high point? No. This graph goes up forever. So there is no absolute maximum. That would be the highest point on the graph, and there's no limit up here. So we will say none to that. What about local maxima? Are there any points at the top of a little hill? Well, yeah. There's a point right here at the top of this little hill. And so I'm just going to put those coordinates. Negative 1.0 comma 0.0. That's my local maximum. Okay, is there an absolute minimum? Yeah, there's one right here. This is the absolute minimum. All right, the lowest point on the entire graph. So we'll just write that down. 0.4 comma negative 2.8. What about relative minima? Well, first of all, any absolute minimum is also a relative minimum. So this is 1, okay, 0.4 comma negative 2.8. All right, counts as both an absolute minimum and a relative minimum. But there's another one. The bottom of this little valley right here is not the lowest point on the graph, but it is the lowest point in this valley. So that is another relative minimum. Okay, so that's negative 1.7 comma negative 0.4. Are there any zeros? Well, zeros are the x-intercepts of a graph. So we have zeros here and here and here. Those points are labeled for us once again. So that's going to be negative 2.0, or I could have just said negative 2. In fact, I'm not going to put the 0.0. So it's negative 2 comma 0, negative 1 comma 0, and positive 1 comma 0. Okay, we have a y-intercept right here at negative 2. So that's 0 comma negative 2. Now let's talk about the end behavior. I'm going to do this much more quickly than I did last time. Remember, this part right here means on the left, and this part means on the right. So on the left, the graph is rising, and on the right, the graph is rising. Okay, so on the left, the function approaches positive infinity, it's rising. And on the right, the function approaches positive infinity because it's rising. So rising, rising, positive infinity, positive infinity. And last but not least, let's handle these intervals of increasing and decreasing. All right, before I do that, I'm going to clean up this graph a little bit. It won't go away. One more chance, yellow. Okay. So, remember, all we care about are the x values. All right, should I write that on here one more time? X values. All right, that's all we want. So I like to go through here and mark off all of my critical x values. And here they are. Here's a critical value, and here's a critical value, here's a critical value, and of course the arrows at the end are very critical. Okay, so I need the x values of all of those points and arrows. So for the arrows, those are infinities. Don't think about the fact that they're going up, because that would make you think that they're both positive infinity. We don't care about that. We're talking x values. X values go left to right. So what kind of infinity goes left and what kind of infinity goes right? So on the far left, this is negative infinity. On the far right, this is positive infinity. Okay, so the arrows will always be negative infinity and positive infinity, left to right. Now, the x values of these other points, it probably would be easier for me just to highlight them. X value, x value, x value. All right, so focus on those and ignore those other numbers. So whatever you do, do not write down negative 0.4 or 0 or negative 2.8. Those numbers are not relevant. Okay, so let's tell our story. If you were roaming this path from left to right, for this part of the path you'd be going downhill, and then for this part of the path you'd be going uphill, and then suddenly you'd be going downhill again, and then next thing you know you'd be going uphill again. Okay, kind of left the path there for a minute. Yeah, that's ugly. OCD! Alright, I said I would be going uphill. That's pretty good. Alright, so downhill, uphill, downhill, uphill. So for the increasing intervals, we are talking about the green parts of the graph. Okay, so this first green part goes from negative 1.7 to negative 1. Okay, I didn't have to put the .0. Always use round parentheses on these increasing and decreasing intervals because at the points themselves they are neither increasing nor decreasing. And the final green part here goes from an x value of 0.4 to an x value of, oh look, positive infinity. So in between we will put a union and 0.4 to positive infinity. Now for the decreasing intervals, all right, which are these red portions. So the first one goes from negative infinity to negative 1.7. And the second one goes from negative 1 to 0.4. All right, and we'll put that union in between. And that is how you analyze a function.